Okay, today I need to show you something that we call a piecewise defined function. It's got three pieces. It's got this piece, which is a parabola shifted to the right. I hope you can tell that's the blue one here. It's got the green equation here is an absolute value that's been stretched, and that's here in the middle. And last but not least, we have the straight line here. But they don't go forever. They only go for little periods of time. So this first one, for instance, it goes from 2 to infinity. It's like this. And from -2 to 2, that's like in between, I'll make them pink, in between these two lines, it's the absolute value in between -2 and 2. And it's this function, the x plus 4, just a simple straight line graph between -infinity and -2. All right, there is a typical piecewise defined function. They're really not that hard. How about if this time I give you the function like that, and you graph what it would look like. Give this one a shot. And by the way, don't do this enter into your calculator thing. We're not doing that. So this is saying this is built of two functions, just y equals x, because this is like y, right? And it's y equals x squared. So it's a straight line and it's a parabola. And you got to ask yourself, okay, so what part of the graph? Where's my dividing line? You know, like last time I had a dividing line here and a dividing line there. This one only has two functions, so I only need one dividing line. And if I were you, I'd put a dotted line down the middle of the graph wherever it divides like that. You don't have to, but that's what I like to do. I'll pause for a second while you make that sketch. All right, so let's see. If you had a straight line, this is just y equals x, and where is it supposed to be? Where x is less than 0. Well, here's the x is equal to 0 line. I'm going to put a border line there because I want to be really careful there. And I'm going to say that it's a straight line with a slope of 1 that only is on the left side of that. Only in this zone do I have a straight line that equals 1. So I'm going to go right up to there, and I'm going to be really careful at this point. Does this straight line own the border there or not? It does not, because it says less than 0. So up to that moment, but not at the border. Okay? So if you didn't have an empty circle right there, you would have not gotten credit, even if everything else was perfect. Okay, now, in this side, where x is bigger than 0, we needed to graph x squared. And x squared generally looks like that. I'd be fine if you had that, but what's the important part? The border. Right now, it doesn't look like anybody owns the border. And that's actually possible, but it says right here that this works at 0. So I should have a filled-in dot inside the open dot of the other one. I know that's tricky, but that's where the border, that's where I'd be looking for, what I'd be looking for to see, did they put the right kind of dot there? Yes? Yes, it is open. I don't know if you can tell that from a distance, but see, it's open. I'll make it more clearly open. All right. And if I can't tell what yours is, then I have to mark it wrong. So you got to really try to be careful about this one's got an open function, this one's got a closed one. If they both had filled in dots, then they're trying to both own that spot, which is impossible. It's either one or the other. Either one function owns it or the other function owns it. Or it wouldn't pass a vertical line test if they're right on top of each other. All right, so that is piecewise functions. I'm going to just give you one more and see if you can do this from start to finish. And I don't have a nice little piece of graph paper for you. If you want to import graph paper, it would take you like 3 touches of your finger in strategic spots. You should be able to get graph paper in there. But either that or just make the best sketch you can of this piecewise defined function. F of x is going to be x squared between negative infinity and 2, it's going to be absolute value of x from 2 to 4, and it's going to be 3x. No, that'll be too big. It'll be x minus 8 from 4 to infinity. See if you can graph that one. I'll pause for a second and give that a shot. So the tips for studying for tests tonight, there's been problems that have not been assigned. You could try those. Go back to assignments and pick out the ones I never gave you. You could just look over problems you did do. There's the answer keys you can check it against. And if there's any particular topic that you find vexing, you can go back and watch the videos for those. You can find them at servervideo.com or davidserver.com. You just got to find the video link. So either davidserver.com or servervideo.com gets you to the daily videos that I record, like this one. We will do some more review in a moment, but this was the thing that was the most new. With only one of them at the very end of your homework before. Now, if you have trouble figuring out like where the dots should be, don't forget you can make an XY chart very easily for any one of these. Like this guy, it's only this between 4 and infinity, and hopefully you figured out that 4 is like over here. And so in this zone here, you're going to be trying to make this line. If you're having a hard time figuring out where those dots should be, make an XY chart for it. But remember, don't just pick any number. We got to pick x's that are between 4 and infinity. So maybe I should pick 4 and be careful to put an empty circle there because it doesn't own that spot. The 4 was owned by this guy. And then I could put in a 5 and a 6 and a 7, and I see what I get for some points. That's a way to figure out where that graph is. Usually people have trouble with that one. I'm always make an XY chart. I'll pause again while you work on it for a bit more. Okay, I'm going to put in a couple border lines here. I like to use these fancy. There's my 4 border line. The other border line I'll make is at 2. And basically, my function now is divided into 3 parts. The left side, middle, and then the right side. It's the x squared function on the whole left side. I hope you know that generally they look like that. Raise your hand if you had that part right. Okay. Then the middle part is the absolute value of x. It might help you to start graphing the absolute value right from here. See what I mean? But it can't actually be to the left of that green line. So again, that's a way to do it. But if you want to be more specific, you can always make an XY chart. XY charts are really handy. That's why I have it in my top 20. Because it can help you graph anything. And since graphing is like a third of math, is about the graphs. To be able to graph anything with XY charts is very powerful. I'm going to pick 2, 3, and 4 because those are the points that are between 2 and 4, right? If I put in 2 in the absolute value, it's 2. 3 is 3, and 4, the absolute value is 4. So 2, 2. 3, 3. Here's, let's say that's 2, 2. And then 3, 3. And let's say this is 4, 4. Okay. Now, do you see that I have a border issue right now? Is that bothering any of you on my graph? I would have a problem with this because my one graph and my other seem to be like touching there on the border. You got to decide who owns that spot. All right, so in the quadratic, when I put in 2 in this quadratic one here, it becomes 4. Over 2 up 4. So which one owns it? Well, I'm going to do it this way. I'm going to make this a nice big open circle to show that I'm not trying to have the black one, the x squared function, own that spot. The middle one, this guy, he owns the 2 because it's got a bracket on it. Did I do that right? No, I might not have done that right. Hold on a second. Absolute value, if I put in the 2 into the absolute value, I get 2 comma 2. If I put in the 2 into the x squared function, I get 2 comma 4. Okay. All right. Sorry about that. This should be higher. Surprised nobody was telling me, but I get. If I go over 2, I should be going up 4. So it's actually not right on top of the other one. There we go. Okay. And then the last one, which is at x minus 8. To figure out where it goes, I'm going to use the XY chart again. I'm going to make 4, 5, 6, 7, and 8. If I put in a 4 into this, I get 4 minus 8, which is negative 4. If I put in 5, 5 minus 8, negative 3. 6 minus 8, negative 2. So I'm going to graph those points. 4, negative 4. So down here, I'm going to put an open spot because it doesn't try to own that spot. That 2 is, or that 4 is owned by the middle one. And then 5, negative 3, it's slowly rising. And 6, negative 2. So those spots. So I'm going to go like that. Okay, hardest thing. Now let's go back and talk about some of the easiest things. But any last questions before I leave this screen? That is called a piecewise function. They're not going to ask you to name it. They're going to ask you to do it. Okay, then what else did we done with functions? One thing we did is tell if it was one or not. Very simple one. Is that a function or not? Yeah, because it passes the vertical line test. All right, what is this a function? I made a tricky one on purpose, but that is a function. If I were to graph those spots, these two are just the same as each other, and that's what you'd expect. If you put in a 2, you should get a 3, right? But as soon as I add this to the mix, is it a function anymore? No, because, again, if you wanted to, you could graph them and see it wouldn't pass a vertical line test. Another way to say it is one input, like 2, should only have one output. And here we've got 2 outputs, 5 and 3. All right, last thing here. Is that a function or not? No, because if I solve it for y, I will get 2 equations. Some people still are not quite sure why, but this is the absolute value of y, and that would give you 2 equations for y. Y equals this and y equals that. If you have 2 equations defining a function, it's not a function. Okay, next thing. Build me a function that adds 4, divides by 3, and then timeses by 2. Build me a function that will do those things in order. I should even number them. It has to first do this, second it needs to do that, and third it needs to times by 2. Did you say f of x was x to start with? That's a good way to start. Okay, now, how do I make it add 4? Well, that's easy, plus 4. Divide by 3. Again, if I just say divide by 3, now the order's not going to be right anymore, because in real life, when you do this, you would divide 4 divided by 3 first, and that's not what we want. We want it to add first. How do we force it to add first? Parentheses, okay. Now, it's going to divide by 3. Now I'm going to say times 2. Now, it depends on how you did this. There's more than one way to make it work. You got to take your answer and then judge it. I would have to do the same. I'd have to look at yours and say, if I do this, would that, what I just wrote, would it do the add first and then the divide and then the times? Would it? Add would definitely be first because it got the parentheses. Okay, we agree on that one? Okay, then once I'm done with that, would divide or multiply naturally come first? Well, they're tied, so you go from left to right. So yes, the divide would have been next, and it's okay the way I wrote it. But if you wanted to be extra sure, how could you just force that to for sure work? Extra set of parentheses. That would make the 4 be first, the divide by 3 be next, and the 2 be last. Even easier to see, even though the other one actually would have worked. Some people I still think multiply comes before divide. It doesn't. Multiply and divide are tied. So you go from left to right. Okay. That's make your own function. Do you want to practice that more, or are we good on that? Okay, I didn't hear it. We good or more? Good, okay. Then, let's talk about, here's a function. What's its domain? Remember, domains are a list of everything that works. Well, a lot of things work in this. Pretty much everything works except what? 0. 0 is the only thing that wouldn't work. Why? Because you might be thinking, well, you can put a 0 here. Yeah, but you can't put a 0 here, where the denominator will become a 0, and that's a big no-no. All right. Here's the official way we say to find the domain. Take the denominator and set it not equal 0, and then solve it. In this case, it's pretty easy to just see in your head, but I'm going to divide by 3. What's 0 divided by 3? It's 0. X not equal to 0. But remember, if all you said was that, I'd have to mark it wrong, because domains are supposed to be a list of everything that does work. So what does work? I would accept a number line answer. Everything except 0 looks like this. I would also have accepted this answer. Negative infinity, but then it stops working at 0. Union with 0 to infinity. That's supposed to be an infinity sign there, sorry. Okay, that's another way to write everything except 0. And the last way I would accept is all reals except x cannot be 0. That's 3 different ways to write that answer. Okay, how about it's got a square root in it and a denominator? Well then, there's all kinds of things that would screw this up. So then it becomes, in my opinion, you write the equation for this guy and what you want to be true about that guy, and then you write the equation for the denominator, and then you put all your answers into one big number line. And then whatever works is your answer. So the denominator is x plus 7 should not be 0. And the top is x minus 5 should be positive or 0. So how do I write that? Greater than or equal to 0. If I solve those two things and put them on a number line, I got it. From here it should be easy. So really, like, do you get what I just did? Because that's the only hard part. After this, you're just going to put your answers on a number line and you got your answer. So what did I do again? I took the square root and I said that it had to be bigger than or equal to 0. Because think about it. Don't you want square roots of things to be bigger than or 0? And some people are bothered by the 0 thing. You can have a square root of 0. It's totally okay. What's the square root of 0? 0. What's wrong with that? Okay. Denominators have to be not 0. See? So if you can get these two equations right here, then this is a snap from there. It's a piece of cake. Okay? So I'm going to add 5 to both sides. X greater than or equal to 5. And here I'm going to subtract 7. X not equal to 7. And if I can just graph those, here's 5. and greater than or equal to 5 goes like this way, right? And then here's 7. Now, oh, it's negative 7. Thank you. Should have showed my work and I wouldn't have screwed that up. The moral of the story, definitely show your work. All right. Honestly, it happens all the time. If I forget to show my work, so often I screw it up. All right. There we go. And this is x is bigger than 5. And remember, the answer to a domain is what works in this function. So what works? Things that are 5 or bigger work. You might be asking, like, well, couldn't the numbers in there work? Well, let's test one. Like 4's in there. If I put in a 4, does it work? Right away, it crashes the square root. I got 4 minus 5 is negative 1. Can't have a square root of negative 1. So no, that doesn't work. If you're not sure, you can draw a number line, take the important spots, and then just like test numbers around in there and see if they work or not. And how do you tell if it doesn't work? If you get a 0 on the bottom, that's a problem. If you get a negative under a square root, that's a problem. All right, let's do one more. What's the domain of that? Hint, trick, question. What's the domain? All real numbers. Why? Because you can't crash it? Is there a way to make the denominator 0? No. Is there a way to make a square root negative? No. Then there's no way to crash it. Another way to think of it is, if I just graphed it, isn't it going to be a parabola? What's the domain of a parabola? All reals. Negative infinity, positive infinity. Nothing crashes it. But what if I had that, and I had it over x, 2x minus 7. Now you got a potential way to crash this thing. So now tell me the domain. All right, hopefully you noticed that thing is supposed to be set not equal to 0. So you go 2x minus 7 not equal 0. Add 7, 2x not equal to, I'm going to be more careful this time, 7. And then I'm dividing by 2, dividing by 2. X cannot equal 7 halves. Is that a good domain? Nope, because I didn't say all the things that do work. So I should say all reals except x cannot be 7 halves. Or I could have written goes from negative infinity until it hits 7 halves and then it fails. Union with starts again after 7 halves, goes to infinity. That's another way to say everything except 7 halves. All right. Last but not least, finish this sentence for me. The y-intercept is where x equals 0. If I let x equal 0, some people think, oh, then it'll crash. It actually won't. If I let x equal 0, do you get the top will be 0, and the bottom will be what? Negative 7. Is that a problem? No, it's just 0. Okay. So, what's the y-intercept of this thing? 0. The y-intercept is where x is 0. 0 on top is okay. All right. How about the x-intercept of this? That's where what? Y is 0. So then it becomes this question. How do I make that thing equal 0? Hint, do I want the bottom to equal 0, or do I want the top to equal 0? I want the top to be 0. If I make the bottom 0, it's not going to be 0. It's going to crash. I want the top to be 0. How can I make the top equal 0? Give me an answer. 0. Put in a 0. The top will equal 0. Is there any possible other answer? Well, let's check. X squared plus 5x needs to equal 0. Anybody heard a wise saying about factoring? What? If you can factor, then you should factor. I like to say it, if you can factor, you should. Know why? Because now I can see easily two things that can make it 0, right? If you can factor it, you should. I factored out the x, and now I can see two ways to make it 0. All right, so moral of the story, factoring always helps. Secondly, y-intercepts are where what? X equals 0. X-intercepts are where what? Y equals 0. If you make the top of a fraction 0, is that okay? Yes, and it just makes the whole thing equal 0. And if you make the bottom of the fraction 0, is that okay? No, that's just going to make it crash. And so that number is not in your domain then. All right. Any last things you want to ask me? Yes. Yes, absolutely. What is f of x plus h minus, we'll just add a little twist, f of h? Hint, first put this in. It's going to be a little messy, but you get that. Then subtract whatever that is. Always just got to break math down to one step at a time. Not sure where to start. Here's where to start. Empty spot squared plus 2 empty spot. I just replaced my x's with empty spots. I'm going to drop in x plus h. And then I'm not going to fall into the trap of thinking this is x squared and h squared, because it's not. It's x plus h and another x plus h, and it's all foiled out in this 4-part answer. All right, so you should have had x squared plus 2hx, or xh, you could reverse that, it'd be fine, plus h squared plus 2x plus 2h. That's the first part. Now I'm going to do this part, minus f of h minus parentheses. Notice I drop in parentheses because f of h is like a y. It's like a variable. And otherwise, you're going to forget to distribute this negative to both parts. Okay? And then f of h is take this, put h in it. H squared plus 2h. Now, negative h squared and negative 2h. And now the cool stuff happens. H squared and negative h squared cancel. 2h and negative 2h cancel. And all we have left is this, this, and this. So it's x squared plus 2hx plus 2x. I was happy to answer that one for you. Any questions? Any parts of that you want to explain more fully? Glad you brought that up. Any other questions at all? Okay, and this is the part again where some of you are going to make the bad call of, yeah, I think I got this. I'm not doing anything over the weekend at all. And I'm just going to come here cold and take the test on Monday. Okay, that's not a great way to go. At a minimum, find something you're not very good at and work on those things this weekend. Just pick, don't work on the stuff you're already good at. That's dumb. Find something that we did just now that was tough for you. Go back into the old, lesson, watch that video over again. All right, now let's see if we can find some more problems in here that you could do. Does that look like one of those piecewise functions? Okay, that'd be an example of one that you could do. Here's one that is a word problem that involves, it's not really a piecewise function, but that's a pretty tough one. This one is like got the piecewise kind of domain thing in it. All these answers are in the answer key. I'm not going to say you have to do this, this, and this, because part of it is it's Rosh Hashanah. We're not supposed to assign homework other than, I can actually today because it won't be due till Monday. Okay, so whatever I would assign isn't due to Monday, and then Rosh Hashanah should mean that if you want to, you can do your homework this weekend. Anyway, bottom line, if I were you, I would do problems to practice, and I would check the answer key, but I'm not going to say you must do this, 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 and this. You should pick what you should do. Okay? So here's another one of these examples with the little A thing. Remember, you always pick a number for A, like that it works like 2, and then just graph that and see what happens. And then graph that and see what happens. That's a piecewise function. It's this when x is bigger than 0, and it's this function when x is less than 0. Again, on the kind that have a little a in them, you just pick a number for a and try graphing that, and then see what changes when you pick a different number for a. All right, so we've done a bunch of review for the test already. There's a few more practice problems that you would find in previous lessons, but no more on this slide for today. And I'm going to just leave it to you now to study whatever topics you need to study. And if you need any more help, Monday is a morning help day. I will be here, sitting in this room, from 7:05 until like about 8 o'clock. So if you want some extra help, you can come in. I just recommend that you do some practice before you come. Don't just say, well, I won't study, but I'll just come in the morning. You're going to need to study a little bit first and then realize what you're bad at so that you can come in the morning and ask me about that. I won't just like entertain you for an hour. It'll be, you can come in the morning and ask me questions, things that you don't know how to do. All right? Okay, that's all I got for you for today.